This is lesson 10-2, areas of trapezoids, rhombuses, and kites. We're going to start off with a trapezoid today. So remember, a trapezoid has two sides that are parallel. We're going to call those the bases, and then they have two sides that are not parallel. So the area of a trapezoid is half the product of the height and the sum of the bases. So it's half the product of the height, so I'm going to multiply the height, times the sum of the bases. So the area equals 1/2 the height, parentheses, base 1 plus base 2. So because the trapezoid has bases which are different lengths, we're going to add them, and we multiply that by half of the height. Now it actually doesn't matter which one's base 1 and base 2. You're going to add them, so it doesn't matter if you're adding the top and the bottom. Or sometimes, in the example that we're going to do, the bases are actually on the left and the right. But the height of a trapezoid is the perpendicular distance between the bases. So the bases are the parallel sides. I'm going to add those together, and then the height is always the perpendicular distance between those bases. So area of a trapezoid is 1/2 the height, parentheses, base 1 plus base 2. So let's look at this example right here. We're going to find the approximate area of Nevada. So here's a picture of Nevada. It's a trapezoid because I have these two sides are parallel and these two sides are not parallel. So my bases are actually on the left and the right. So my area is 1/2 the height, parentheses, base 1 plus base 2. So let's substitute in the height. The height is the distance, the perpendicular distance between the two bases. So my height is 309. So 1/2, 309, parentheses. And my bases right here are the parallel sides. So one base is 205. And one base is 511. So I'm going to do 1/2 of height, 309, parentheses 205 plus 511. And then you're just going to add these together, multiply it times 309 times 1/2. You can have your calculator do the whole thing for you. So that's a trapezoid, and the formula is 1/2 the height, base 1 plus base 2. Okay, also for today we're going to do rhombuses and kites. Now we actually already learned something for a rhombus. A rhombus is a parallelogram, so you can always do one base times height, but sometimes we're not given that information. Another way to find the area of a rhombus, and it's also the way to find the area of a kite, is half the product of the lengths of its diagonals. So the area of a rhombus or a kite is half the product of the length of its diagonals. So you're going to take the two diagonals, you're going to multiply them, and you're going to take half of that. So it's 1/2 diagonal 1 times diagonal 2. So you have to multiply both the diagonals. So we have diagonal 2, which is in red. This one's a little bit harder to see. Diagonal 1 is in blue. So I multiplied the two diagonals and take half of that. Same thing goes for a kite. I'm going to multiply the two diagonals together, and I'm going to take half of that. Now, an important thing to remember in a rhombus and a kite is that these diagonals are perpendicular. Okay, so if you're missing one of them and they give you a side and say one of the diagonals, then we're going to use the Pythagorean theorem to find that missing diagonal. Okay, or sometimes we might use angles, like if it's a 30, 60, 90 or 45, 45, 90, we'll use those to find missing lengths of diagonals. So I need to know both of the diagonals in order to do this. So we'll look at an example where they actually give us all the information. So I'm going to find the area of kite KLMN. So I have diagonal LN, and actually it's just giving me the pieces. So this half is 3, and this half is 3. And then KM, this is 2 right here. The 2 should be for this part. And then this is 5. So the area of a kite is 1/2 diagonal 1 times diagonal 2. Diagonal 1 is going to be 7. I'm adding the 2 plus the 5. Okay. And diagonal 2 is 3 plus 3, which is 6. So it's 1/2, 7 times 6. And you can just do that in your calculator and make sure that you get 21. Okay, so again, the 2 is not the side. There's an arrow pointing down, but it didn't get into this picture. So the 2 is for this part of the diagonal there. All right, and we have another example. A rhombus has sides of 10 centimeters long. Okay, remember a rhombus has all sides congruent, so all the sides are 10, and the longer diagonal is 16. It doesn't matter, but this one looks a little longer, so we'll call this one right here 16. Okay, so this diagonal 16, which actually means half of it is 8. And that's important to know because I want you to try and figure this out. So this whole diagonal 16, we can label it. This half is 8, and then this side of the rhombus is 10. Remember what I said, if you're missing a diagonal, this is a right triangle right in here. So you can always use the Pythagorean theorem. So we're going to use the Pythagorean theorem. This will be the missing diagonal right here, half of it. So we're going to call this x. X squared plus 8 squared equals 10 squared. Okay, and once you find this little section, I'm going to have to double it to find the whole diagonal, and then I'm just going to multiply half of diagonal 1 times diagonal 2. So I have one of the diagonals. One of the diagonals is 16, but I'm going to use Pythagorean theorem to find that other missing diagonal because they actually gave me the side. Okay, so try and label your diagram. Use the Pythagorean theorem. Again, the side is 10, that's the hypotenuse. The diagonal is 16, so this half is 8, and this is x. So I'm going to use the Pythagorean theorem, x squared plus 8 squared equals 10 squared to find this missing diagonal, this missing half, and then I need to double it. Okay, so try that, and then we're just going to work on some more problems tomorrow.